Okay, let us now look at some properties or highlights of an AP. Okay. Now the first property is if we add, subtract, multiply or divide each term of an AP with a non-zero constant. Non-zero constant. If we add, subtract, multiply or divide each term of an AP with a non-zero constant, then the resulting sequence will also be an AP. The resulting sequence, I'll just explain what I mean by it, will also be an AP. Right? What I mean by it is, let us take an AP. Let us take this AP A plus D, A plus 2D, and so on, A plus n minus 1 into D, A plus n minus 2 into D here. Right? Now, if I add a non-zero constant in each term of this AP, let me add K. So, if I add K in first term, it will be A plus K. K in second term, it will be A plus D plus K, A plus 2D plus K, and so on, A plus n minus 2 into D plus K, and the last term A plus n minus 1 into D plus K. Now if you observe this sequence here, the resulting sequence, this is also an AP. Why? Because when you subtract any term minus its previous term, right, then what do you get? When you subtract this from this, A will get cancelled, K will get cancelled, you will get D, right? When you subtract this second term from third term, A will get cancelled, K will get cancelled, and 2D minus D, you will again get D, right? So this resulting sequence is also an AP with same common difference, which is D. Now this common difference will not be same in each of these cases, or let us check each and every case, then we will comment about it, right? But in case of addition, I can say that if I add a non-zero constant in each term of this AP, I will get a resulting sequence which is also an AP with same common difference, that is D. Now when I subtract, addition and subtraction are same processes, right? So even if you subtract K from each term, you will have a resulting sequence as an arithmetic progression with same common difference D, right? You can do it yourself, the subtraction part. Now if I multiply each term with a non-zero constant K, the resulting sequence will be A into K plus comma A plus D into K, A plus 2D into K, right? And what will be the last term? A plus n minus 1 into D into K, right? Now look at the terms. If I subtract, right, any term minus its previous term, so A into K will get cancelled, and what about D K minus K? It will give you D minus 1 K here, right? Now what about this common difference? A will again get cancelled, 2dk minus dk, again you will have dk. This I made a mistake here. See, this will be ak plus dk, right? When I subtract this, AK will get cancelled and I'll have D into K. When I subtract second term from third term, I'll again have D into K, right? So the common difference in this case is D into K. Hence, I can say this resulting sequence is an AP with common difference as D into K. So if I multiply each term of an AP with a non-zero constant K, the resulting sequence will also be an AP with common difference as D into K, right? And what about division? When I divide each term by K, then it will be A by K, A plus D by K, A plus 2D by K, and so on till A plus N minus 1 into D by K. Now you check whether it's an AP or not. How do we check? By checking whether the difference of any term and its previous term is a constant or not. So when I do this subtraction, A by K will get cancelled and I'll have D by K, right? So which is a constant. Hence this resulting sequence is an arithmetic progression, but the common difference is D by K here. So if I divide each term of an AP by a non-zero constant K, the resulting sequence will also be an AP with common difference D by K, right? So what was our first property? If we add, subtract, multiply or divide each term of an AP with a non-zero constant, the resulting sequence will also be an AP. In case of addition and subtraction, the common difference will remain the same, that is D of the original sequence, right? If we multiply, the common difference will be D into the constant that we multiplied it with, and when we divide it, the common difference will be D divided by K, where K is the constant, non-zero constant with which we divided the original arithmetic progression. So this is the first property here. Now the second property that I want to talk about here is, let us say I've got two APs. First AP is A plus D, A plus 2D, A plus N minus 1 into D. And let there be another AP with first term as capital A, second term as A plus D, that means the common difference is capital D. So what will be the third term? A plus 2D. And what will be the nth term? A plus N minus 1 into D. If I add these two APs, right, I've got two APs, first AP, second AP. If I add the respective terms of these two APs, first term with first term, let us say, second term with second term, so I'll obtain a sequence that is A plus A, and here I'll have A plus D plus D, and third term I'll have A plus 2D plus 2D. So let me take 2 as common, so I'll write it like this, okay. And what will be the nth term? It is A plus N minus 1 can be taken as common, and we can write D plus D, right? Now if you observe this resulting sequence, when I added two different APs, that is the respective terms, the first term with the first terms, corresponding terms of two APs, first term with first term, second term with second term, and nth term with nth term, then the resulting sequence is also an AP, right? How do I check that? I'll check this difference. When I subtract this first term from second term, I'll get D plus D. When I subtract second from third, A plus A will again get cancelled. I have got 2 D plus D and this is 1 D plus D, so the difference will be D plus D. So yes, there is a common difference which is small d plus capital D, hence this resulting sequence is an AP with common difference as sum of common differences of these two APs that we added, right? So if you add two different APs, the resulting sequence will also be an AP with the common difference as the sum of common differences of these two APs. And now you can check about the subtraction yourself, right? So the next highlight that I would like to discuss is that the common difference of an AP, can be positive, negative, or zero, right? So I may have a positive common difference, a negative common difference, or zero. In case of positive common difference, it will be an increasing AP. In case of negative common difference, it will be a decreasing AP. And in case of zero, all the terms will be same. So let D be a positive number. So if I write A plus D, A plus 2D, right? This is an increasing AP, right? Now if I write A minus D, A minus 2D, this is a decreasing AP. And if I take D as 0, then I will write A, all these terms will be A, and the common difference obviously is 0. So common difference can be positive, negative, or 0. In case of positive common difference, the AP will be an increasing AP. Let me write a particular AP for you. For example, 2, if I take first term as 2 and common difference also as 2, then the AP will be 2, 4, 6, 8, 10, and so on, right? This is an increasing AP. Each term is more than its previous term. Now if I take, let us say, first term as 5 and common difference as negative 2, so what will be the AP? 5. Then 5 plus minus 2, that is 5 minus 2, which is 3. Then again subtract 2, 1. Then subtract 2, minus 1. Subtract 2 to obtain the next term, minus 3. So this is an AP with first term as 5 and common difference as negative 2, and you can see that this is a decreasing AP. Each term is lesser than its previous term, right? And when I take D equal to 0, I can give you an example like this: 5, 5, 5, 5. This is also an AP with common difference as 0, right? One more thing that we have already discussed that I would like to write as a highlight, that the sum of terms equidistant from beginning and end, equidistant from the beginning and the end, sum of terms from equidistant from the beginning and end is equal, right? This is another highlight of an AP. Okay. Now let me talk a little bit about sum of n terms of an AP. I am denoting it with this S and this small n as a subscript. Let it be sum of n terms of an AP. Okay. Now I want you to observe one thing before talking in detail about the sum of n terms of an AP. That when I write, let us say, A1 plus A2 plus A3 plus A4, let us say up to an minus 1 plus an. So this is sum of n terms of an AP, right? What is sum of n terms of an AP? That I write the n terms of this AP and add these, right? This is very simple. So if this is Sn, what can you say about these terms up to an minus 1? This will be sum of n minus 1 terms of an AP, right? Sum of n minus 1 terms of an AP. So obviously we are talking about sum of first n terms of an AP, right? Beginning from the first term going up to nth term. When we take the sum, it is Sn. Beginning from the first term, when I go up to n minus 1th term, then the sum of these n minus 1 terms is Sn minus 1, right? Now if I have to calculate this nth term in terms of Sn and Sn minus 1, can I say that nth term is nothing but Sn minus 1? Yes, because this expression here is nothing but Sn minus 1, and I can take it on the left hand side. So Sn minus 1 is equal to nth term. So another way of obtaining nth term of an AP is sum of first n terms of that AP minus sum of n minus 1 terms of that AP will give you the nth term of that AP, right? So let us discuss about sum of first n terms of an AP in details in next lecture.